Today, we'll be presenting about Sequence and Series Chapter 3. Our group consisted of 4 people. SYAZWAN HARIZ, AA240182. Muhammad bin Nasir, AA241372. Muhammad AZRI, AA240628. And Muhammad DZAQIRIN ISYRAF, AA241305.
The introduction of this topic and slides of our group is mathematical sequences and series, particularly arithmetic and geometric progression, are essential tools for solving real-world problems across various industries. These concepts help model and optimize processes by analyzing patterns of growth, reduction, and change over time, allowing businesses to make data-driven decisions. The application of arithmetic and geometric sequences in real-life scenarios highlights their importance in enhancing productivity, optimizing operations, and ensuring better outcomes across diverse fields. So, for task 1, we will list the unknown, which is A is 2, the first term, D is 4 for the common difference, and AN is 30. So, by using the formula AN equal A plus N minus 1 times D, we will substitute the unknown by each of the number, and we will get N is 8, which is the 8 maintenance checks after 20 hours. For question 2, calculate the total time spent on maintenance if check takes 30 minutes. So the total check is 8, so 8 will be multiplied by 30 minutes, and we will get a total of 240 minutes, which is 4 hours. So for part 2, the output increased by 5, which after every third. So after every third checks, it will increase by 5, and the first third is 5, the 6th is 10, and the 9th is 15. So we will sum it all, and we will get over 30 units.
Now, I will present our solution for task 2, precision manufacturing. In this task, we analyze how material is removed during a machining process following a geometric sequence. Let's dive into our problem. The problem states the first cut removes 8 mm of material. The fourth cut removes 1 mm. Our objective are to find the common ratio, calculate the depths of the second and third cuts, determine the total material removed after 8 cuts, and find the geometry mean between the first and the fourth cut. The second is geometric. So the formula for the nth term is AN equals to A times R to the power of n minus 1. So for the fourth cut, 1 equals to 8 times R3, which means R3 equals to 1 over 8. After we simplify that, we get R equals to 1 over 2. So the common ratio is 1 over 2. Using the same formula, we calculate for the second cut. A2 equals to A times R, which means 8 times 1 over 2, where we get 4 mm. And for the third cut, we will get 2 mm. For the third solution, the formula for the sum of the first nth term in a geometric sequence is Sn equals to A times 1 minus R to the power of n over 1 minus R. Substitute it, we will get sum of 8 equals to 8 times 1 minus 1 over 2 to the power of 8 over 1 minus 1 over 2. After we calculate it using calculator, we will get 15.94 mm. For the last question, The geometric mean between the first and fourth cut is calculated as G equals to square root A times B, where A equals to 8 and B equals to 1. G equals to square root 8 times 1, square root 8. So we will get the answer approximately around 2.83 mm. To summarize, the common ratio is 1/2. The second and third cut remove 4 mm and 2 mm respectively. The total of material removed after 8 cut is 15.94 mm, and the geometric mean between the first and the fourth cuts is 2.83 mm.
Okay, thank you Long for task 2. Okay, now we go to task 3. The question, a machine pipe undergoes stress testing where the stress follows this sequence. The question gives 64, 16, 4 and 1. Okay, the first question, find the sum of the infinity series. We use S infinity equal A over 1 minus R. A we got in question is 64. R we got 16 over 64, we get 1/4. Is that common ratio? Okay, now we go to question 1. S infinity equals 64 over 1 minus 1/4. We get 256 over 3. Okay, the question 2, find the sum of the first system. We use the formula Sn equal A 1 minus Rn, 1 minus R source of power n over 1 minus R. 1 minus R. Okay, we get S6 equal 64, 1 minus 1/4, source of power 6 over 1 minus 1/4. We get 85.31. Okay, for the question 3, insert 2 geometric means between 64 and 4. Okay, we go the first step, we use R3 equal 4 over 64, we get 1/60. Okay, now we can use R equal 1/60, source of power 1/3, we get 1/2. Now we find the number between 64 and 4. First, we use 64R equal 64 1/2. We get 32. The question 2, the number 2 is we use S1, the answer 1 and R. We get 32 1/2. Can get 16. Okay, the last question is prove that the sequence is geometric. Okay, we do 60 over 40 equal 1/4. 4 over 60 equal 1/4. 1/4 equal 1/4. Since the ratio is constant, R equal 1/4, the sequence is geometry.
Okay, let's begin for the task 4. Employee training program. An employee training program begins with 5 sessions in the first month, increasing by 2 sessions every month. A. how many training sessions will be held in the 6th month? We know that unknown is A equals to 5, B equals to 2, and N is 6. We use formula AN equals to A plus N minus 1 times D. So for the AN is 6 equals to 5 plus 6 minus 1 times 2 equal to 15. The total training session is 15 sessions. B. What is the total number of sessions conducted over the first 8 months? We use Sn minus n over 2, 2a plus n minus 1 times d. We know that the unknown is a is 5, d is 2, and n is 8. So 8 over 2, 2 times 5 plus 8 minus 1 times 2. So the session is 96 sessions. And C, critical thinking. If management wants to cap session at 15 within a year, will they need to adjust the monthly increase? Why? So the number of the year is 12 months. We use Sn equal to n over 2, 2a plus n minus 1 times d. So the equation is S12 equals to 12 over 2, 2 times 5 plus 12 minus 1 times 2. The session is 192. This is well over 15 sessions. Therefore, the D increase needs to be reduced. Yes, the monthly increase needs to be adjusted. Thank you.
Okay, now we go to discussion. First, this problem emphasizes real-life application of algebra concept. First, arithmetic progression are used to model regular linear change in maintenance schedules, training program, and production rates. Two, geometric progression capture exponential change such as material reduction in machining or stress decay. Third, critical thinking scenarios encourage analyzing constraints and making decisions based on mathematical modeling. Okay, the second discussion, we get the question serve as a comprehensive approach to applying algebra to optimize industrial and organizational process. Let me know if you would like solution for specific task or additional insight.
Okay, for the conclusion, for the all result of every task. For task 1, an arithmetic sequence is used to count the number of maintenance inspection in a given time, while the total maintenance time is analyzed through a progressive change. Furthermore, task 2, an arithmetic sequence is used to count the number of maintenance inspection in a given time, while the total maintenance time is analyzed through progressive change. For the task 3, the concept of infinite series helps to calculate the total amount of stress applied, while the common ratio proves the properties of geometric sequence is the test. Last but not least, the task 4, the arithmetic sequence is used to plan employee training session while considering resource constraints and schedule optimization in a real world context. Thank you.